every wave that breaks against the shoreline carries a story written in fragments of our own creation plastic. It drifts silently across oceans, sinking into sands, tangled in sunlight. Once it symbolized progress, convenience, a material that changed the world. But today it lingers reshaped, eroded, yet immortal. In 1950, humanity produced just 2 million tons of plastic. By 2025, that number will exceed 600 million. And every year, more than 8 million tons of it flow into our oceans, a torrent of our modern lives, set adrift. Plastics are born from oil-long chains of carbon atoms bonded together. They were designed to last forever, but forever has a cost. Under sunlight and salt, they fracture. Waves grind them down, ultraviolet rays shatter their bonds. What was once a bottle becomes a shard. What was once a shard becomes a grain, and eventually a microplastic. These are the unseen children of our convenience particles, smaller than 5 millimeters, sometimes invisible to the human eye. They swirl in the same currents that once carried fish, plankton, and life itself. Microplastics travel the world, carried by wind, washed by rivers, released through every drain. From the Arctic ice to the Mariana Trench, they have reached places untouched by human feet. Even the rain carries them. In 2019, scientists found microplastics falling from the sky over the Pyrenees, a place once considered pristine. The storm had carried them from cities hundreds of kilometers away. They are in our rivers, in our soil, in our breaths. And yet their story does not begin in the sea, begins with us. Microplastics are not just waste, they are a byproduct of living modern life. Every time we wash our clothes, synthetic fibers escape into the water: polyester, nylon, acrylic. A single load of laundry can release 700,000 fibers, each one small enough to pass through wastewater filters. From tires wearing down on city roads to microbeds in cosmetics. From degraded packaging to industrial dust, the sources are endless. Every action we take, washing, driving, cleaning, producing, leaves behind traces we cannot see, but which nature cannot forget. The rivers of our world have become highways for microplastics. The Yangtze, the Ganges, the Nile, they carry billions of fragments every day, from land to ocean, from civilization to the unknown. In 2020, a study found that just 10 rivers transport more than 90% of the plastic reaching our oceans. The burden is global, but the fingerprints are ours. Once released, these fragments become impossible to reclaim. They are lighter than sand, smaller than seed sand, infinite in their persistence. They move through water, yes, but also through us. Every sip we take, every meal we eat. Every breath that drifts through the air, invisible to the eye, yet measurable inside the human body. The story of microplastics begins with creation, but where it ends, we have yet to understand. This is the legacy of plastic. The ocean has always been Earth's cradle, vast, living network that sustains life on our planet. But today, that cradle is suffocating under a storm of plastic dust. What was once invisible is now undeniable. Every wave, every current, every creature is touched by microplastics. These particles don't just float. They sink, they rise, they travel across entire oceans, from the tropics to the poles. Scientists have found them in the Mariana Trench, the deepest point on Earth. No ecosystem is untouched. The tragedy begins at the smallest level. Plankton, the very foundation of the ocean food web, mistakes microplastics for food. A single plankton cell can absorb fragments far smaller than a grain of sand. Once eaten, the plastic doesn't digest. It accumulates, blocking the organism's ability to feed. And as small fish eat the plankton and bigger fish eat them, the poison climbs the food chain. This chain from microscopic plankton to massive whales forms the backbone of life in the sea. But now, every single link is contaminated. Researchers have found microplastics in 90% of studied marine species, including many of the fish we consume daily. Even the coral reefs, the vibrant rainforests of the sea, are being smothered by this plastic dust. These tiny particles cling to coral surfaces, blocking essential light and harboring harmful bacteria. As a result, corals struggle to breathe, to feed, and to reproduce. The delicate balance of reef ecosystems, already under threat from a warming climate, now faces a second invisible enemy. In the heart of the Pacific, a massive vortex known as the Great Pacific Garbage Patch spins endlessly. It's not a solid island of waste, but a toxic superbillions of microplastic fragments suspended in the water. Sunlight breaks larger plastics into smaller and smaller pieces, wave by wave, decade by decade. What we see on the surface is only a fraction. Most microplastics have already sunk, forming a synthetic sediment on the ocean floor. In some regions, the concentration of microplastics on the seabed now exceeds that of natural particles like plankton or organic matter. The ocean floor, once a sanctuary of biodiversity, is slowly becoming a plastic desert. Above the waves, the story is just as grim. Seabirds mistake colorful fragments for fish eggs. They then feed them to their chicks, unknowingly delivering poison disguised as food. Thousands die each year with stomachs full of plastic, not the nutrition they need to survive. For marine mammals, plastics bring both suffocation and starvation. Entanglement kills and ingestion weakens. Dolphins, seals, and turtles are all victims of a pollution they never caused. And yet, the ocean's suffering is not isolated. When we eat seafood, we consume the ocean's burden. Studies reveal that an average seafood lover ingests up to 11,000 microplastic particles every year. What begins in the ocean doesn't end there. It returns to us molecule by molecule, bite by bite. Around the world, oceanographers are racing to map the true scale of this contamination. But the more they look, the deeper the problem seems to go. Microplastics have become part of the marine snowther, organic rain that sinks nutrients to the deep sea. They are woven into the ocean's very heartbeat. Even the abyss, a world once believed to be untouched by human hands, now glows with traces of plastic. Microfibers have been found in amphipods living more than 6 miles below the surface. Humanity's footprint has reached the deepest, darkest shadows of our planet. The ocean story is a mirror of our own. What we release into the water eventually flows back into our lives. The impact of microplastics is not just an environmental issue, it's a moral one. The ocean gives us life, food, and climate stability. And now it quietly asks for mercy. Every sip we take feels pure. Every drop of water, symbol of life, renewal, and clarity. But hidden beneath that clarity lies a secret the human eye cannot see. In laboratories around the world, scientists are finding something unsettling: tiny synthetic fragments, microplastics, floating in our drinking water, embedded in salt, and even carried through the air we breathe. We are living in an era where plastic has entered our bloodstream. Microplastics are everywhere in rivers, lakes, rainwater, and tap systems. In 2018, researchers from the State University of New York tested bottled water from 11 major brands across 9 countries. The results: 93% of all samples contained microplastic particles. The average liter held more than 300 particles from polyethylene terephthalate, the same plastic used in the bottles themselves. Plastic breaks down, but it never disappears. It travels through the air, falls with the rain, and enters the groundwater. From there, it flows through our taps, our crops, our food chain. Recent studies have discovered microplastic fibers inside human lungs. Others found them in the placenta, the very shield between mother and child. For the first time in history, plastic is not just an environmental contaminant, a biological one. Scientists call it the plastic age signature, a mark of humanity's synthetic legacy etched into our own biology. So, how does it get inside us? There are 3 main pathways. We ingest it, we inhale it, and it can even enter through our skin. Let's start with ingestion. Microplastics have been detected in seafood, salt, sugar, honey, beer, fruits, and vegetables. The average person consumes around 5 grams of plastic every week, roughly the weight of a credit card. Imagine swallowing a credit card every single week. That's what the data suggests. Mussels and oysters, for example, filter seawater, trapping microplastics, and we eat them whole. Sea salt produced through evaporation retains microplastic residues. Even our drinking water, both bottled and tap, carries this invisible polymer dust. Then there's inhalation. Indoors, we breathe in microfibers shed from synthetic fabrics like polyester, nylon, and acrylic. They float in the air, settle on our food, and accumulate in the lungs. According to one study, the average human breathes in over 20,000 microplastic particles per year. Finally, dermal absorption. Some personal care products like exfoliating scrubs and certain cosmetics contain microbeds. These tiny spheres can potentially penetrate through pores or small wounds, bypassing our natural barriers. Once inside, where do they go? This is the mystery haunting scientists. Some larger particles might pass harmlessly through the digestive system, but the smaller ones, nanoplastics, are small enough to cross cell membranes, enter organs, and maybe even penetrate the brain. In 2022, Italian scientists detected microplastics in human blood samples for the first time. Out of 22 healthy volunteers, 17 tested positive. The plastics found included PET, polyethylene, and polystyrene, the same materials used in packaging and styrofoam. These findings suggest that microplastics can circulate through the bloodstream, potentially reaching vital organs like the heart, lungs, kidneys, and brain. The smallest fragments, nanoplastics, are 1,000 times thinner than a human hair. At this microscopic scale, they can interact directly with our cells, potentially generating inflammation, oxidative stress, and possibly altering DNA expression. Some researchers believe this could accelerate aging, cause hormonal imbalances, or even trigger cancerous changes. But the truth is, we are only at the beginning of understanding this. When microplastics entered the body, our immune system sees them as invaders. White blood cells rush in, trying to engulf the foreign fragments. But plastic doesn't degrade. The result? A state of chronic inflammation, a silent war waged within our own bodies. In animal models, prolonged exposure to microplastics has been linked to liver stress, reproductive issues, and hormonal disruptions. What's more, microplastics can act as carriers. They absorb other environmental toxins like mercury and PCBs, transporting them directly into our tissues. In essence, every piece of plastic can be a Trojan horse chemical cocktail cloaked in a microscopic shell. Perhaps the most alarming discovery came from studies of the human placenta. In 2020, Italian researchers identified microplastics in 4 out of 6 placentas they examined. The particles were found on both the maternal and fetal sides. This means the next generation is exposed to plastic even before birth. What long-term effects this will have on immune development, brain growth, or future fertility, no one knows for sure. The data is still emerging, but the implications are profound. The womb, once the most protected space on Earth, now carries traces of human pollution. We have reached a point where humanity has become inseparable from its own waste. Across continents, research is accelerating. But results often differ, not because the threat is uncertain, but because the scale is almost beyond measurement. The challenge is immense. Microplastics come in countless shapes, sizes, and chemical compositions. Standardizing how to detect them and understanding their cumulative effects could take decades. The World Health Organization acknowledges the presence of microplastics in drinking water, but states that more research is needed to determine direct health risks. Meanwhile, many environmental scientists argue that waiting for absolute certainty is a dangerous gamble. The longer we delay, the deeper plastics integrate into our biology. So, what do we know, and what are the unknowns we must face? We know microplastics exist in our blood, our lungs, and our organs. What we don't know is the critical question: how much is too much? How does long-term exposure affect fertility, childhood development, or neurological health? Do nanoplastics cross the blood-brain barrier? Can they alter our microbiome, the vast, invisible ecosystem inside our gut? Early evidence suggests that microplastics can disturb the balance of gut bacteria, potentially weakening immunity and increasing inflammation. Some models even hint at links to autoimmune diseases and metabolic disorders. But without decades of long-term studies, the true cost remains hidden. In many ways, this is the new frontier of medicine, where environmental science meets human biology. The question is no longer if microplastics are inside us, but what they're doing now that they are. Every plastic bag, every bottle, every single fiber we release into the world eventually returns to us in some form. Our oceans, our soil, our air, they are all connected. The cycle is complete, and the source is us. The human body is 60% water. When we contaminate the planet's water, we ultimately contaminate ourselves. But there is still time to change course. Awareness is the first step. Innovation can follow, from improved filtration systems to biodegradable materials. The race is on to protect not just our planet, but our own biology. Every cell in our body carries the memory of the environment we create. The ocean flows within us. The rivers run through our veins. What we give to the earth, it gives back to us for better or for worse. The story of microplastics is a story of reflection. It's a mirror of our civilization's excess and a test of our collective wisdom. The question remains, will we learn in time? Across our blue planet, a quiet race is unfolding, not for gold or oil or land, but for truth. The truth about what we've done to the water that sustains all life. From the Arctic to the Amazon, from the Himalayas to the Pacific depths. Scientists are following a trail invisible to the naked eye, yet present in every drop, the trail of microplastics. The first step toward understanding any crisis is to measure it. But how do you measure something smaller than dust? Microplastics exist in countless shapes and densities. Some float, some sink, some are fibers, others are films or pellets. Each one behaves differently, rifting with currents, clinging to sediments, or traveling through the air itself. Tracking them requires technology as advanced as the challenge itself. Today's laboratories use Fourier transform infrared spectroscopy, or FTIR, to identify the unique molecular fingerprint of plastics. Others employ Raman spectroscopy, capable of detecting nanoplastics smaller than 1 micron. The goal is to create a global map of contamination, a living database of the planet's plastic burden. Every new study adds a pixel to this global picture. And the more we look, the clearer and more alarming that picture becomes. No single country can solve this alone. Microplastics know no borders. They travel across oceans, through clouds, between continents. So, the scientific community has built alliances from the ANEP Global Partnership on Marine Litter to the Global Plastic Pollution Observatory in Japan. Research vessels from the University of Tokyo are sampling the North Pacific JER, the spinning heart of the Great Pacific Garbage Patch. In Germany, the Alfred Wegener Institute is drilling Arctic ice cores to measure plastic particles trapped in frozen time. In Chile, scientists are tracing microplastics in mountain glaciers, melting into rivers that feed entire ecosystems. These expeditions are not just scientifics. They are acts of endurance. Each vial of water carried back to the lab represents hours of collection in extreme conditions. Storms, freezing winds, blinding sun. But inside those vials lies the evidence humanity needs to confront its own reflection. At first, scientists thought microplastics were a marine problem. But now they're finding them in the air, from the Alps to the Pyrenees, from London to Shanghai. Microfibers are drifting through the atmosphere like synthetic pollen. In 2021, a French study revealed that microplastics fall from the sky even in remote mountain regions, carried by wind thousands of kilometers from their origin. It means that no place, no matter how isolated, is truly untouched. What we once believed was a distant ocean issue is now a planetary one, woven into the global circulation system itself. To understand ocean plastic, scientists turned to the source: rivers. The world's 10 most polluted rivers are responsible for up to 90% of the plastic entering the ocean each year. Among them are the Yangtze, the Ganges, and the Niger. These rivers serve billions of people for drinking, agriculture, and industry. But they've become highways of plastic waste, transporting micro and macro debris from land to sea. Using satellite tracking, drones, and AI-driven flow models, scientists can now predict where plastic accumulates, helping cleanup teams target the most critical zones. Technology and data have become our compass in the plastic age. To truly understand how deep the problem goes, we must follow the plastics to their final resting place, the abyss. In the past decade, robotic submersibles have explored depths exceeding 10,000 meters, retrieving sediments from the world's darkest corners. The findings are chilling. Microplastics embedded in seafloor mud accumulated over decades. Some samples show plastic concentrations 5 times higher than surface waters. The ocean floor, once thought to be a refuge, is now a plastic graveyard. Yet, even here, life adapts. Deep-sea amphipod-shrimp-like creatures have been found with microfibers in their stomachs. Humanity's reach has extended beyond sight, beyond sound, into the eternal dark. But where there's discovery, there's also innovation. Scientists are developing new tools to detect and filter microplastics in real time. Drones can now identify surface plastics via hyperspectral imaging. Smart buoys collect ocean samples automatically, transmitting data via satellite. In Singapore, engineers are experimenting with graphene-based membranes filtering, even nanoplastics at the molecular level. In Sweden, a startup uses magnetized nanoparticles to attract microplastics from wastewater, a technology that could revolutionize water treatment plants. Step by step, science is fighting back, building the tools to reclaim purity from pollution. Not all heroes wear lab coats. Around the world, ordinary citizens are joining the effort. Through open-source initiatives like the Big Microplastic Surveys, people collect water samples, analyze particles, and upload their results to global databases. From students in Kenya testing lake water to divers in Australia monitoring reefs, the movement is spreading. Each test, each measurement adds another piece to the puzzle. Together, they form the largest environmental research network in human history, united by a single belief that data is power. Big data has become the microscope of the modern age, with millions of samples, petabytes of data. And machine learning algorithms, scientists can now predict where microplastics will travel decades into the future. Ocean circulation models reveal how a plastic bottle discarded in Indonesia can end up on the coast of California. Atmospheric simulations show how synthetic fibers from a city can rain down in the Arctic. It's a hauntingly beautiful dancer digital reflection of the pollution we've created. But within that data lies hope. The power to foresee, to mitigate, and perhaps one day to reverse the damage. Despite progress, challenges remain. Funding is limited, standardization is difficult, and the political will often lags behind science. Yet, amid the struggle, there is unity. Each discovery, each data set, each voice builds the foundation for action. The journey from ignorance to awareness is humanity's greatest transformation, and awareness once awakened cannot be undone. In the vast expanse of the cosmos, ours is the only planet known to carry liquid water and life. And now, even as we confront the invisible threat we've unleashed, we also hold the power to heal it. Across continents, in labs and classrooms, on ships and in homes, people are working, learning, and fighting for the same thing: the right of future generations to drink clean water. This is science in motion. This is humanity rising to its greatest challenge. And this is the beginning of understanding it. Every drop of water tells a story of life, of movement, and now of contamination. But in laboratories and factories, in deserts and coastal cities, a new chapter is being written, one where technology meets necessity. Humanity's oldest challenge, purifying water, is being reborn for the microplastic age. Thousands of years ago, civilizations along the Tigris, Nile, and Indus discovered that filtering water through sand and charcoal could make it cleaner. They didn't understand molecules or polymers only, that clean water meant survival. Through centuries, filtration evolved, from woven cloths to carbon filters, from clay pots to complex industrial systems. Yet none of them were designed for what we face today. Particles smaller than light can reveal, plastics born of our own invention. In today's cities, billions of liters of water are treated every day. The journey begins with coagulation and sedimentation, removing visible debris. Next comes microfiltration and ultrafiltration membranes that act as microscopic sieves, blocking particles down to 0.1 microns. These systems capture most microplastics, but the smallest nanoplastics, measuring less than 1/1000th of a millimeter still, slip through, unseen and unfiltered. The cleanest water we've ever produced may not be as clean as we think. To catch what the eye can't see, we needed filters beyond imagination. Enter nanotechnology. Modern engineers now design membranes at the molecular level, materials so fine that only pure HO molecules can pass through. Graphene oxide, carbon nanotubes and nanocellulose fibers are at the heart of this revolution. These ultra-thin sheets of carbon are incredibly strong, flexible and precise. They can filter water with minimal energy, resist fouling, and last far longer than traditional systems. At the University of Manchester, scientists have created graphene filters capable of removing 99.9% of nanoplastics while maintaining flow speed. Meanwhile, in Singapore and Seoul, startups are testing large-scale prototypes for municipal water supplies. What was once a laboratory curiosity is becoming an industrial standard. Nature has been filtering water for billions of years with elegance and zero waste. Inspired by that, scientists are turning to biomimicry. The lotus effect, the natural water-repelling property of certain plants, has inspired hydrophobic surfaces that resist plastic adhesion. Coral structures and fish gills have led to multi-layered filters that capture particles without clogging. These bio-inspired filters are self-cleaning, energy-efficient, and biodegradable, the opposite of the problem they're solving. In a poetic twist, life itself may teach us how to undo the damage we've done. Not all filtration requires barriers. Some use forces invisible, yet powerful. Scientists have discovered that magnetic nanoparticles coated with surfactants can bind to magnets. Once attached, the particles and the plastics can be removed magnetically, leaving the water clear. This technique, pioneered in Sweden and Canada, could revolutionize wastewater treatment. It's fast, cheap, and requires no high pressure or membranes. Imagine cleaning entire lakes and rivers with nothing but magnets and sunlight-powered drones, a vision already being tested in early pilot programs. The greatest challenge isn't discovery, it's implementation. How do you retrofit millions of existing water plants worldwide to deal with microplastics? Some nations are already leading the charge. Switzerland has mandated advanced filtration for all treatment plants. Germany and Japan are testing tertiary microplastic capture stages using ceramic and polymer membranes. Singapore's Uniwater program reclaims 40% of its waste, water filtering it so thoroughly it becomes drinking quality again. Each country is a testing ground, an evolving experiment in how humanity redefines clean water. Innovation isn't confined to labs. Around the world, startups and NGOs are creating portable filtration devices for individuals and communities. From life straw to soya, millions now rely on handheld filters that remove bacteria, parasites, and increasingly microplastics in regions without stable infrastructure. Solar-powered desalination units and nanofiber membranes bring hope. In crisis zones from flood-struck Pakistan to drought-hit Kenya, clean water isn't a luxury, it's survival. With every portable filter, every purifier, the gap between technology and humanity narrows. The next frontier is intelligence. Artificial intelligence is transforming how we clean water, from predicting contamination surges to optimizing filter performance. Sensors embedded in filtration systems continuously analyze flow, pressure, and particle size. AI algorithms adjust membrane cleaning cycles, saving water and energy while improving purity. In South Korea, smart wastewater plants have achieved a 25% reduction in maintenance cost using AI optimization. In Denmark, real-time microplastic detection systems are connected to national data networks, allowing instant response to pollution spikes. The result? A living, adaptive filtration ecosystem, one that learns as it cleans. With freshwater dwindling, desalination has become the backbone of water security for millions. But even seawater carries microplastics, and removing them during desalination is no small task. Engineers are now integrating dual-stage membranes, combining reverse osmosis with nanofiltration layers specifically tuned for microplastic capture. In Israel and Saudi Arabia, pilot plants have reported near-zero plastic output, proving that clean water from the sea is not only possible, but scalable. Desalination was once seen as the last resort. Now, it may be the key to a plastic-free future. The world is awakening to a new reality. Clean water is no longer defined by clarity, but by purity on a microscopic scale. From nanofilters to AI-driven systems, from biomimetic membranes to magnetic particles, humanity is reinventing the very concept of water purification. And yet, technology alone cannot save us. It must be paired with awareness, education, and prevention. The purest water will mean little if the source remains polluted. But for the first time in centuries, we hold in our hands the power to reverse the float, to clean what was once thought irreversibly tainted. The tools are here. The knowledge exists. All that remains is will. Because every drop we save today shapes the ocean we'll inherit tomorrow. For decades, we've watched the problem grow. Microplastics, once invisible, now undeniable, drifting through our rivers, our oceans, and even our veins. But this story doesn't end in despair. Around the world, scientists, governments, and everyday people are rewriting the final chapter. A chapter about solutions and about responsibility. Awareness is the first wave of change. From classrooms to parliaments, the term microplastic has entered our collective vocabulary. What was once confined to scientific papers is now headline news, school lessons, and social media conversations. In 2018, when researchers detected microplastics in human stool samples for the first time, that discovery shocked the world. It proved that the problem had breached the boundary between our environment and our own bodies. Soon after, policymakers began to act. The European Union banned microbeds in cosmetics. Canada, the United States, and the UK followed. Today, over 100 nations have restrictions on single-use plastics. It's not yet enough, but it's a beginning. Every ban, every new law is a ripple in the global current of change. Policy is the invisible infrastructure of civilization. It shapes markets, habits, and our future. And now it's shaping how we use and abuse plastic. In 2022, the United Nations Environment Assembly passed a historic resolution to create the world's first legally binding treaty to end plastic pollution. Nearly 175 nations signed on, a rare moment of unity in a divided world. The treaty aims not only to limit production, but to build a circular economy, one where plastic never becomes waste, and every molecule is reused or repurposed. Extended producer responsibility laws now hold corporations accountable for the full life cycle of their products. This means if you make it, you must also help remove it. It's no longer just about consumers recycling bottles, it's about re-engineering an entire economy. The next revolution isn't in cleanup, it's in design. Engineers are now creating plastics that biodegrade under natural conditions. Companies are investing in closed-loop production systems where every bottle, bag, or fiber returns to its origin. From mycelium packaging to seaweed-based films, materials science is reinventing how we package, ship, and consume. These new plastics don't outlive us by centuries. They dissolve back into nature in a matter of months. Even major corporations, under global pressure, are pledging 100% recyclable or biodegradable packaging by 2030. The message is clear. Waste is no longer inevitable. It's an engineering problem, and it's one we can solve. While policymakers act on land, innovators are reclaiming the seas. Projects like the Ocean Cleanup now deploy autonomous vessels that sweep through gyres, those massive whirlpools of drifting plastic, capturing tons of debris at a time. In rivers, AI-powered barriers detect and remove waste before it ever reaches the ocean. In India and Indonesia, low-cost cleanup machines operate 24/7, powered entirely by sunlight. For the first time in history, we're not just talking about stopping pollution, we're actively reversing it. Every ton removed is a message. We can heal what we've broken. The cleanest plastic is the one that never enters the environment. That's why scientists are turning to source prevention, redesigning the very systems that shed microplastics before they can escape. New textiles are being woven with low-shedding fibers, dramatically reducing microfiber release during washing. France has already passed a law requiring all new washing machines to include microplastic filters by 2026. Car manufacturers are tackling tire dust, developing wear-resistant tires and roadside filtration systems. Paint industries are reinventing coatings to prevent microparticle shedding. The shift is underway from reaction to prevention. Because once microplastics enter the water, removing them is exponentially harder. But policy and science are only half the equation. Real change begins with people. Every choice from refusing a straw to supporting sustainable brands sends a signal. Billions of small actions multiplied daily form the tide that drives systemic transformation. Education is our most powerful filter. When young minds grow up understanding the cost of plastic, the cycle of pollution can finally break. In Kenya, school programs now teach children to identify and recycle plastics. In Japan, communities hold annual microplastic audits of their local rivers. And online, digital activism connects millions who refuse to accept a plastic future. Awareness is contagious. Hope, even more so. As technology evolves, so must our ethics. We can create membranes that filter molecules, but we must also cultivate minds that filter choices. The future of water will be defined not only by science, but by conscience. Artificial intelligence, automation, and biotechnology can restore balance, but only if guided by human empathy. The question is no longer, can we fix it? It's, will we choose to? It's microplastics. Remind us that our planet has no borders. A bottle discarded in one nation becomes dust in another's rain. The ocean connects us, whether we realize it or not. So this must be our shared promise to protect the waters that define us, to ensure that future generations inherit rivers that sparkle, oceans that breathe, and rain that gives life, not plastic. The microplastic crisis is vast, but so is our capacity for innovation, cooperation, and compassion. We've seen what technology can do to the world. Now we must see what it can do for it. In this vast web of life, every drop matters. The fight against microplastics is not just about science. It's about identity, responsibility, and legacy. Our generation stands at a crossroads. One path leads to clearer water, cleaner skies, and restored harmony. The other to a world slowly suffocating in its own creation. The choice is ours. The time is now. This is the HydroVerse, where science meets survival, where awareness becomes action, and where every story begins with water. If this episode opened your eyes, help us open millions more. Like the video, subscribe to HydroVerse, and share your thoughts below. Every voice adds momentum. Every share spreads awareness. Join us on this journey as we dive deeper into the hidden world of water.